name is Jonathan Hall, and today I'll be reviewing number 12 for the math final. Pictured is a cylinder inscribed in a sphere of radius 4 inches. The height of the cylinder is twice the radius of the cylinder. Find the volume of the cylinder. First, I found the equation needed, which is the volume of the cylinder. Next, I was looking at the diagram and saw that the radius of a sphere is 4 inches. And the cylinder touches the edge of the sphere, which can also be used in a radii, which I wrote down here. So I drew one radii and one radii and created a triangle. But I split that in half because this right here is the height, or is half the height of the cylinder, and I need to find the height in order to complete the problem. So it's a 45, 45, 90 degree triangle. So these two are essentially the same in length, and this is the radius of the sphere. So there's two ways to go of this. You can either use the Pythagorean theorem or trigonomic functions. So I'm going to do the Pythagorean theorem first. So start off, the Pythagorean theorem should look like c squared is equal to a squared plus b squared. This is because you don't know the two legs, but you do know the hypothesis. So anyway, I wrote down the 4 squared is equal to the radius of the cylinder squared plus the radius of the cylinder squared, which these are the two legs. So then I added them, because since they're like terms, and I got 4 squared is equal to 2 radius squared. So then I squared the 4, and I got 16 is equal to 2 radius cylinder squared. To get rid of that 2 in front, I need to divide by a 2. That's what I did, and I got 8. Then I got 8 is equal to radius cylinder squared. To get rid of that squared, I need to square root the radius cylinder in the 8. So that's what I did, and I got 2 square root of 2 is equal to radius of the cylinder. Now for the trigonomic function, I drew another diagram of the triangle, and I used sine of SOHCAHTOA. And I did sine of 45 is equal to radius of cylinder over 4, which is opposite over hypotenuse. So then, since another value for sine of 45 is 1 over square root of 2, I substituted sine of 45 in for, or the other way around, or 1 over square root of 2. So then I got 1 over square root of 2 is equal to radius of cylinder over 4. To get rid of that 4, I needed to multiply by 4. So I put 4. I said 4 over 1 for this side, and then 4 over 1 for that side, and I multiplied it, and I got 4 over square root of 2 is equal to radius of cylinder. But I'm not done yet, because you have to rationalize the denominator. And so then I multiplied top and bottom by square root of 2, and then I got 4 square roots of 2 over 2. But 4 and 2 can reduce each other, so I reduced 4 to 2 and 2 to 1. So then I got 2 square roots of 2 is equal to the radius of the cylinder, which is the same thing for the Pythagorean theorem. So then I took the volume equation and put it down here, and I substituted in the radius. So it is volume is equal to pi times 2 square roots of 2 to the second power times 2 times 2 square roots of 2. And the reason why the 2 is here, because in the problem it said the height is twice the radius. So I used the 2 times the radius. So that's where that 2 comes from. So then I I solved for it, and I distributed the 2 into 2 square roots of 2, and I got 8. And then 2 times 2 square roots of 2 equals 4 square roots of 2. So then I multiplied 8 times 4 times square roots of 2, and then I got 32 square roots of 2. So then I rearranged it around, and I got volume is equal to 32 square roots of 2 times pi. That concludes the problem number 12 for the math final. And my references were my mom and Khan Academy. Thank you.